Hi everyone. For today's video, we're going to be going over lesson 4 of this chapter, which talks about something called a recursive formula. So what I'd like you to do, we have a warm-up here, 4 questions. Just pause the video for a moment. What you're going to be doing, once you pause the video, you're going to be reading through these 4 examples that give you a term and a rule, and you're going to just continue the sequence based on the rule. Okay, so pause the video, give it a try, and then we'll go over it. Okay, so for question 1, it tells you that the first term is 7, and the rule is that you're going to be adding 3. So here's my first term of 7. Think of that as our A1. And if I'm going to just continue to add 3, then my next term would be 10. That would be my A2 term. Then I would add 3 again. I would have 13, then 16, then 19. Okay, so that's the sequence for question number 1. And if we're adding over and over again, that's an arithmetic sequence, just like we have studied, previously in this chapter. Okay, number 2 says the first term is 80. So here's that first term, and I'm dividing by 2. So you can think of that as, multiplying by 1/2, or think of it as, dividing by 2, same idea. I would get then for my second term 40. Now I'm going to continue dividing by 2 or multiplying by 1/2. My third term would be 20, then 10, then 5. So since we're technically multiplying, even though we're saying division, we're multiplying by the same value over and over again, this would be a geometric sequence. So we can label these if we want. This is an arithmetic sequence. This is a geometric sequence. Okay, number 3 says we start with the first term of 1. Okay, so that's listed for us. We're going to square that number and then add 2. So this is neither arithmetic or geometric, nor geometric, since it is not a constant addition or a constant multiplication of the same number over and over again. We're doing 2 different things here. So if I squared, I'm just going to do this down here. If I squared 1 and then added 2 to it, 1 squared is 1. 1 plus 2 would give me 3. So that would be my second term. Now I'm going to do the same thing. I'm going to square 3 and then add 2 to it, right? Because it says square the number, then add 2. So if I square 3, I get 9. 9 plus 2 is 11. I'm going to keep going. Now I'm going to take 11. I'm going to square that and then add 2. So 11 squared is 121, and then 121 plus 2 is going to give me 123. So this is my third, that's my fourth term, and then let's get the fifth and final term. For this one, definitely take a calculator out at this point. Since we are taking the number 123, we're squaring that, and then we're adding 2. So 123 times itself gives you 15,000. I'll write this down here. 15,129. And then we're going to add 2 to that, and you should get 15,131 as your fifth term of that sequence. Now, that's neither arithmetic nor geometric, but it's a pattern, it's a sequence, and we were able to continue the pattern just by knowing the rule and where we started. Okay, so question 4 is also giving us a rule, multiply by 2 and then add 1. But if you're pausing for a second on this one, when you went through this one, if you said, that one doesn't seem quite right, it's because it isn't. So they gave us a rule, but the problem is we don't know where to start. So we can't just say, take a number, multiply it by 2 and add 1 and continue a sequence if you don't have a starting term to begin your pattern with. So I just want you to add a little note here. We cannot do this since we do not have a starting term. So this entire warm-up was you practicing recursive formulas without even knowing that they were called recursive formulas. So let me just start off by saying a recursive formula is a different way to be writing the terms in a sequence. So to list out the terms in a sequence, you can use one of two formulas. Explicit formulas are what we have worked with since day one. Those are the formulas you have on your reference sheet for arithmetic and for geometric. Recursive is a completely different type of formula, and it's a formula that is similar to what we just did in the warm-up. It's going to give you some rule and a starting term. So that's what a recursive formula is. It has two parts, a term and a rule to continue a pattern from that term. So let's just go back up. So a recursive formula requires a starting term and the same rule. So it has to also be the same rule applied to each term to get to the next term. It requires you to know the previous term, right? So if you go back to our warm-up, I would never have, let's just say, been able to find 13 if I didn't know 10, right? Because what was I adding 3 to get to 13? Well, I had to know that the previous term was 10. And how did I get to 10? I had to know the previous term was 7. So with recursion, you need to know the term before. How did I get 20? Well, I took half of 40. How did I get 40? I took half of 80. How did I get 11? Well, I squared 3 and then I added 2. How did I get 3? I squared 1 and added 2. So recursion is all about going one term at a time and knowing the previous term. Okay, so let's just look at a basic example. So in recursion, we must know the previous term in order to find the next term. So here's just a really basic example. It tells me A1 is 6, so that's my starting term, and it also happens to be the first term of the sequence is 6. Then the rule. Now this is where it's going to look a little funny here. I'm going to explain it in a moment. But this is a rule that says add 2 to get from term to term. And you're not going to maybe recognize that at first. So let's talk about where this, especially this piece here, where is this coming from? So if I have a term a sub n, and I want to talk about the term before, think about n. N tells me the position of the term. Again, so when we knew that 6 was the first term, we knew that because there's a 1 here. It tells me the position. So if I wanted to talk about the term before, let's think of this as a sequence. If I knew the position, let's say the position of this term was the third position, the third term. How would I get the term before that? Well, the term before the third term would be the second term. But mathematically, what am I doing? I'm subtracting 1 from that position. So a sub n minus 1, all that means is the term before the one you're trying to find. Because the formula is based on a sub n, just like explicit formulas were based on a sub n. So you're trying to find the nth term. Well, what are you basing the formula or the rule on? The term before. And then what is it saying is happening to the term before? We're adding 2, and that was our rule. Now, if you wanted to talk about, let's say, the next term, you would add 1 to your position. Okay, so if you ever saw a sub n plus 1 in a problem, that would just mean the next term, not the previous term. Previous term, you subtract 1 from position. Next term, you add 1 to the position. Okay, so let's try an example. So example 1 gives us a starting term. The first term they tell us is 4. So let's list that here. Okay, the nice thing about recursion also, they tell you a starting term, so you always know one term in the sequence. So it's kind of, it's giving you that first term to start out with. Now we're being asked to do this rule, a sub n. This is my rule. I need to kind of decode it. So I'm going to take a highlighter here and I'm going to highlight this because we already know what this is. A sub n minus 1 just means the term before. So let's see what's happening to the term before. I'm going to physically rewrite this with those words in place of a sub n minus 1. So what does 3 and then a parenthesis mean? This means 3 times the term before. And then what are we doing? Plus 2, then add 2. So this is our rule. It's nicer sometimes to spell it out like that than to look at it, in the symbolic way that it was written. Okay, so if I want to get to my second term, I'm going to take 4, I'm going to multiply it by 3 and add 2. Since if I'm trying to find the second term, 4 is the term before, right? This is the term before the second term. All right, so 3 times 4 is 12. 12 plus 2 is 14. Then if I wanted to keep going, now I'm going to take 3. I'm going to multiply it by the term before the third term, which would be the second term. So that's 14. So 3 times 14, that's going to give me 42. 42 plus 2 is going to give me 44. Okay, let's do this one more time. Now I'm going to the fourth term. So the term before the fourth term is the third term. So I'm going to multiply 44 by 3 and then add 2. So 3 times 44 should give you 132. Add 2 to that, you get 134. So again, just to focus on this, we wanted to find the fourth term. So we took the term before it, which was the third term, and we multiplied it by 3 and added 2. When we wanted to find the third term, we took the second term, we multiplied it by 3, we added 2. When we wanted to find the second term, we took the first term, we multiplied it by 3 and added 2. The only term we didn't have to find was the first term because they always give you a starting term. Okay, let's keep going. Let's try another example. Okay, example 2 gives us a starting term of 3, so that's my first term, and then a rule. So again, I'm going to highlight this, and I'm going to rewrite my rule. So negative 4 times a sub n minus 1 is just the term before, minus 5. So negative 4 multiplied by the term before, and then subtract 5. And if you want to rewrite it, a little bit more specific, so negative 4 times the term before. That's what you'll do first. Multiplication, comes before addition or subtraction, and then subtract 5. Okay, so if I want to go from the first term to the second term, I'm going to take negative 4. I'm going to multiply by the term before the second, which is the first, which is 3, and then I'm going to subtract 5. So negative 12 minus 5 is negative 17. Okay, then I'm going to find the third term using the term before it, which is the second term. So again, we're basing it on the term before. So negative 4 times the term before is negative 17 minus 5. So at this point, we're taking 17 times 4. They're both negative, so that's going to become a positive 68. And then 68 minus 5 is going to give me 63. I want to find the fourth and final term. I'm going to base it on the term before. So negative 4 times the term before the fourth, which is the third term, minus 5. So 63 times 4 is 252. Oh, but we have a negative, sorry, now we're back to negative. So negative 4 times positive 63 is negative 252, and then a negative 5 brings that number to negative 257. Okay, so now let's look at another example given to us slightly different, but still referring to recursion. So number 3 says the pattern below, if it continues, which equation is a recursive formula that represents the number of squares in the sequence. So let's first identify this pattern. So they're telling us the number of squares is how this pattern is being represented. So if we look at design 1, there's 1, 2, 3 squares. Design 2, 1, 2, 3, 4, 5. Design 3, 1, 2, 3, 4, 5, 6, 7. Okay, I think I see the pattern now. Let's do one more. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this pattern appears to be a sequence that starts with the number 3. And then, so let's say that's, A1, our starting term is 3. And the rule is that we're adding 2. So if you take a look at choice 1 and choice 2, these can't be recursive formulas because they're a couple of reasons. They're both written as linear functions in mx plus b form, which we do know is a way to write an arithmetic sequence because arithmetic sequences are linear in nature. However, recursive formulas have to have 2 parts. They have to have a starting term and a rule. So these formulas are only written as rules, so they could not be recursive. So now let's look at choices 3 and 4. So if you notice, both of these rules are written based on the term before, and they both say to add 2. So they both have the correct rule, but what they both don't have is the first term correct. So number 3 says the starting term is 3, which I agree with. So that's why this one's the answer. Number 4 says the starting term is 1. So yes, there is a first term, but it's not 1, it's 3. So that one is choice 3. Okay. The only other thing I want to mention before you try the practice today is that sometimes, just like with explicit formulas, these formulas can be written in function notation. So if they're in function notation, f of 1 just represents the first term. So instead of a sub 1, which also means the first term, they could write f of 1. And I've even seen sometimes where they write a of 1. So instead of f, they use a. But this is function notation, and this is subscript notation. And this is function. So if we were saying f of n is the term I want to find, how would I represent the term before? In function notation, it's the same thing. You're going to subtract 1 from your position, and if you wanted to find, let's say, the next term, you would add 1 to the position. So if you saw a question talking about a recursive formula, and instead of subscript notation, you saw this, f of n minus 1 is the same as a sub n minus 1. They both just mean the term before the term you're trying to find. Okay, the way that you're going to practice this, so at this point you hopefully have watched this video. If you had to repeat any part, that's fine. You could always pause, rewind. You should have completed these 3 questions and all the other parts of the notes. They should be filled in your notes packet. And what you're going to do for the practice is you're going to scan this QR code, and there are 6 questions. There's workspace here. We want to see all of the work written out. You can check your work as you go through these task cards. They're like index cards. So the question's on one side, the answer's on the back. But we still want to see all the work that you tried all 6 questions, and you're going to submit these 6 questions and all of these pages of notes to us on Canvas for today's submission. If you have any questions, please message us or email us. Okay, have a great day.